Okay, so we're analyzing these four statements when P is false and Q is true. So we're always setting P equal to false initially, and Q initially is always equal to true. So we want to find out which one is true. And in the first scenario, we have that AND statement, and that requires both P and Q to be true in order for it to be true overall. However, we just stated that P is going to be false and Q is going to be true. In this scenario, this is a false statement. The next one, we have that OR statement, and that is right here, that V, or sometimes a U, usually a V though. And we have not P, so whatever P was to begin with, in this case it's false to begin with, it starts out now true. Or we have Q, right, which is also true. In that scenario, this is a true statement. So that seems to be the answer. The next one, a biconditional, well, P if and only if Q, and that means that in order for this to be true, both P and Q must match. Either they're both false or they're both true, and since P and Q are opposites, right, this can't be true. One's stuck at false and the other's stuck at true. When you have this scenario right here, you can think of PEMDAS, where first you deal with what's inside the parentheses, P or Q. Now P is false and Q is true, so one or the other, and at least one of them is true. So overall, that's a true statement. However, we then negate that. We take the inverse right here. So we have the inverse of true, which must be false. That's a false statement. And again, this was a false statement. And so is this one. So the answer here is the second one. All right, hope that helped.